Hello everyone, welcome to the next class on the theory of the testing of the hypothesis. Today we will discuss about the ChiSquare test independence of the attribute. Myself Dr. Gar, working in the School of Mathematics, Thapar Institute, India. If you feel any doubt, you can contact me by either of the email IDs are there. I will love to solve your queries are there. So we have seen in our last lecture that there are many applications of the chi-square distributions. We have seen that which are listed in the goodness of the fit, independence of the attributes, some population proportions are there. So the first one, that is the goodness of fit test, we have covered in our last lecture. Now in this video we will discuss about the independence of the attributes. You can find the goodness of the fit video through this my YouTube channel link, which is available here. So what we have seen in our last lecture, that is the goodness of fit. We have seen that frequencies are given to you which are occupied only in a single row. So that single row is also called as the one-way classification. But right now in this lecture, we will see that we will discretize this frequency into the row and the columns are there. And such distributions of the tables is called as the contingency table. So look at that. If there are the two attributes, attribute 1 and attribute 2, and attribute 1 is discretized into the R parts and these are the C columns are there. And if you look at about the particular case of the R cross C, this is a 2 cross 2 and your attributes are my attribute 1 and attribute 2 and these are the values are there. And in this chi-square test our task is to check whether the attribute 1 and attribute 2 are independent or not. That is the task of this chi-square test. So if you look at this R cross C table, then what is the degree of freedom is there? So if there is only one row, then we have seen that n minus 1. Now since there are the R rows are there, so it's R minus 1 for the row and this is for the column and they are the independent, so we can multiply them. So if you see about that 2 cross 2, then what's the degree of freedom is 2 minus 1, column are 2, 2 minus 1 is 1 is there. Now how you calculate the value of the chi-square? So we can calculate the chi-square value as O minus E whole square divided by E with a degree of freedom as this. We can also calculate the chi-square value by using this second method, but this method is applicable only for 2 cross 2. Remember that. So what is that? If I have the 2 cross 2 values A, B, C, D. So what we do is that we can firstly find the sum of A plus B here, A plus C this, and so on. This is a total. Either you can find the total column wise or this by this way. Once we are finding here, then we can calculate the chi-square directly as n, that is the total number, AD minus BC, that is the determinant of this, divided by this, multiply this, multiply this, and multiply this. So this is the first method. This is the second method, or otherwise you can calculate also by this way. So that is depending from the problem to problem. I always prefer this one, but remember that this method is applicable only for the 2 cross 2. Also we have seen that what will happen in the Zeta correction when the Zeta correction is applicable. So what we have seen in our last lectures are there, when any of the frequencies are less than 5 in the chi-square, then the method of the then the calculation of this exact test is not applicable directly. So what we do that we have to pool them so that the total frequency must be greater than 5. So once we will combine the frequencies to make them greater than 5, then the degree of freedom will be lost. So in that case, for example, if I say 2 cross 2, the original degree of freedom is my 1. If any of the frequencies less than 5, say 2, 10, 11 and 9. So look at that, this frequency is my less than 5. So it means the 1 degree of freedom is lost. So in that case, the degree of freedom is my 0, 1 minus 1, 0. So which is very absurd. So whenever the degree of freedom is 0 or the frequency which is less than 5, then we will apply this Zeta correction of continuity. What we do in this Zeta correction of continuity is we will add the 0.5 to all those values which are less than of the 0.5. For example, if I have these numbers, since this number is less than of the 5, we will reformulate this table by adding this number by adding 0.5 to this number, and we can adjust the remaining values in such a way that what is the total of the first lines are there, these are my total. So in this table the total will remain the same, so we can adjust the value in this in such a way that now it's a 2.5, now it's 8.5. So we will see in the couple of the examples are there. Example number third, we will see that this case. So once it is a 2 cross 2 again, then we will apply the chi-square directly by using this, or we can find chi-square value as by using this rule also. So remember that this Zeta correction is applicable only for the 2 cross 2. It is not applicable for the R cross C. And whenever n is very large, then this chi-square is not much affected by the Zeta correction. But if n is my small, then this Zeta correction is much influence on that. So we will discuss the some illustrative examples are there. We will discuss these 6 or 7 examples in this video, and these 3 steps we have to use them. So let's discuss with the first example is that these are the information given to you according to the statement. What is that? This is the some areas which are rural and urban are there, and these are the vote for the peoples for the candidate A. These are my candidate A, and this is my candidate B. And now look at that. There are the two attributes. One is the area, second is my peoples. Okay, so these are my two attributes, and in the chi-square test, the null hypothesis are always be attribute 1 is independent of the attribute 2, whatever the attributes are there. For example, in this case, what is the attribute 1 is nature of the area. This is my attribute 1. What is the attribute 2 is votes for the candidate, that is a preference of their elections. So what is my null hypothesis is attribute 1 is independent of the attribute 2. Always remember that in the chi-square, the null hypothesis is independent. Now what we do is, now second step is we have to calculate the value of the E and chi-square. So what we do firstly is we can add them, this plus this here, we will calculate these numbers. Now there are the two methods we can calculate this chi-square, because this matrix is again a 2 cross 2. Okay, because look at that, these are my information, this is a 2 cross 2. So we can apply, there are two methods for finding the chi-square. One is this, second is this. Okay, so if you apply this method, then this is my N, this is my A, this is B, this is C, and this is D. So we will see that. So if you apply this method, this O is my observed frequency which is given to you. Our task is to find this E, that is called as the expected frequencies. So how we find the expected frequencies? Look at that. So in order to find the expected frequency corresponding to this 620, we will see that this is 1000 and this is 1170. So we will find that this multiply this multiply this divided by total. So we can find this number. Similarly, we can find for the other four numbers are. But if you think about that, these are the four calculation parts are there. In order to reduce the calculation, we will apply this second method, and I always prefer this one. So what we do in this method is we will find the degree of freedom. Firstly, how many rows are there? 2. Columns are 2. So the degree of freedom is my 1. So instead of finding these four values, you can find only the one values, while rest we can calculate it easily. So look at that, we can calculate any one of the values. So assume that I calculate for the first value. It means the value of E corresponding to this is 585. Now how you find the remaining three values instead of finding again all these? Look at that, the total is my 1000. So it means what is the value of this? Is 415. So that total is 1000. Look at that, total is 1170. So what is the value of this? Is 885. Look at that, total is my 830. So the remaining value is my 415. So this is the way you can see that all values are same. So once we are finding here, then we can write here. So this is the area. Look at that, the areas are my rural and urban. So I can write the first column as rural and urban. The value corresponding to rulers are 620 and 380. So 620 and 380. And this is the value of the E we have computed as 585, 415, this and this. Once you are finding here, you can find the O minus E whole square and solve. So you will get this number. So this is the formula. This is the first method. You can compute the value of the chi-square. And the second method we can compute the value of the chi-square is by using this rule. So what we do is, this is my N. This is A into D minus B into C. So once we see, you can see that all the values are same. 10.09165, 10.0916. Now once you do, then step third is we have to calculate the degree of freedom. Degree of freedom is 1. You have to draw the graph. The value of this is calculated tabulated value. 3.841. Now look at that, what's the value of the chi-square is 10.091. Where it lies? 10.9 here. So it lies in the rejected region. So it means it is highly significant. So rejected H0, it means they are rejected the independent. So it means the nature of area attribute 1 is related to the preference value. It means they are not independent. Look at the second examples are there. So there are the public opinion about the two questions. So now these two questions are my attributes. So what is my null hypothesis is these attributes are independent of each other. So what is my question one is, do you drink? Second question is favor on the local opinion. So look at that, the local opinion is this, the two attributes are independent. What is that? Local opinion. Question B is my local opinion is independent on the question A, that is do you drink, whether or not the individual drink. Again you can see that this is a 2 cross 2, so again there are the two methods you can calculate, and also you can see that none of the frequency is less than 5. So it means if none of the frequency is less than 5, then this Zeta correction is not applicable. So now this is my H0. Now you can find the value of E. Look at the degree of freedom is my 1. So corresponding to these four values, we can find the sum. Corresponding to these four values, we need only compute one values B. I can find the 56, 87 into 74 divided by this. So you will get this as a 58. Now once this is 58, you can find the remaining numbers also. So what is that? This is my 16 because total is 74. This is 24. This is 16. This is now my 8. Now look at that. This is my 37. Now this is 8. So what we do? This is my 29. Now all these values are calculated as my E. So what we do is now we can write as a question number B. This is my yes and no. So the yes answers are there 56 and this is now my O. 56, 31. O is my this B. So you can write like this way. So this is my question number B and this is no. 56, 31, 18 and 6. So this E we have computed as 58, 29, 16 and 8. So look at 58, 29, 16, 8. So once we will solve this, we will get here. Now again you can see that this is a 2 cross 2. So instead of finding this chi-square by using this method, you can also find the chi-square by using this method. So in this case, this is my N. This is my AD minus BC. So this is AD minus BC. So you can see that 956A is the same answer. Now what is the step third is you can find the degree of freedom. This is 1. So this number is my 3 point this. So 0.9568 lies here. So remember that this is accepted. So always remember that whenever H0 is accepted, we use the term as may be accepted. We are not 100% sure that these are always accepted. So since this is less than, so it is not significant. So the null hypothesis may be accepted. So we conclude that the local opinion is not dependent on that. Look at the third example is there. So if you carefully look about these values are there, this frequency is less than 5. Look at that. So since this value is less than 5, so we apply the Zeta correction of that. So what we do in this Zeta correction is in order to find the value of the chi-square, so we will add, look at that, the cell frequency 2, that is the first cell, is less than 5, so we apply the Zeta correction. So what we do is firstly we can find the total 16 and 12 is there. Okay. Now what we do is those number which are less than of the 5 we can add 0.5 in this case. So now this you can delete this number. Now remaining is 2.5. We can add 0.5 to all those frequency which are less than 5, and now we can adjust others b. Now the total is 8, so this value is now remaining is my 5.5. Now total is 12, this is my 5.5, so this is my 6.5. Total is my 16, so this is my 9.5. So we will convert this into here. Now you can define the H0, so is not independent. Degree of freedom is again as a 1, so instead of finding all those values, we need only one independent entries. So we can find is as, for example, 2.5. So this as 12, this is 8 divided by total. So this is my 4. So the expected value is my 4. So now total is 8, so this number is also 4. The total is 12, so this number is 8. This 12, this is 8. So now you have finding the values of this as a 4. You can find the other values. So now this is insulate vaccine. So values are 2.5 and 9.5. Novax to 5.5 and 6.5. So this value is my 4. What is the value corresponding 9.5 is? Total is 12. So this is my 8 and so on. Now you can find the remaining values. You can see this value is 1.6875. Okay. Now what is the step third is? We have find the degree of freedom as a 1. So the value is here. So 1.65 lies here. So we can say that we may be accepted at 5% level, and you conclude that vaccine is ineffective. That means they are not independent. Look at the one more example is there. Now this is, you can see that this is my 2 cross 4 entries are there instead of the 2 cross 2, and one frequency is less than of the 5. Okay, so can Zeta correction is applicable? No, this method is not applicable because this method is applicable only for the 2 cross 2, but this is 2 cross 4. So what we do is we can firstly find the null hypothesis, that is the data information is independent. You can see that the sampling by the are significant. You can see they are independent. You can find the sum of this. Since Zeta correction is not applicable, so we can find the value of E. Now there are the 3 degree of freedom. Look at, there are 2 rows, 4 columns are there. So degree of freedom is my 3. So instead of finding these 8 entries one by one, instead of writing this 8 of this, 8 of 40, 8 of E of 60, and so on, we can find independently 3 values are there, and we can find the remaining accordingly. So we can find the corresponding these values. What is the E of 60, 86 is 200, 126 and 300. So this value is my 84. Look at the value of the 2 is 100, 12 and 3. So the value of here is my 4. Similarly, you can find the other values are there. This is my 23. So once we are finding here, you can find the remaining values also. So look at that. This is my 126. This is my 12. So this is my 8. This is my 69. This is my 23. So this is my 46. This is my 84. This is my 42. Okay, now these two values are pending. Now look at that, the sum is my 100. So you can find this number. Sum is my 200. You can find this number. So based on, once you are finding all those values of E, you can write this table. So researcher X, what are the values of the X are 80, 60, 44, 10. So 80, 60, 44, 10, and similarly for the Y. Now can you find this O minus E? No, because one of the frequency is still less than of the 5. So how you find that? We can combine, we can pool them. Okay, so we can combine them such that values are greater than 5. Now it's greater than 5. The corresponding this is there. So this is 27. This is 27. So now here is 27. Now you can find their difference. Okay. Now this is my 0.927. So what is the degree of freedom is? What is the R minus 1, C minus 1? R minus 1 is my 2 rows and 4 columns are there. So degree of freedom is 3. But we have to subtract 1 also because of this pooling. Okay. So look at that, the degree of freedom is my 3 minus 1. This 1 minus is due to the method of the pooling. So the value of the chi-square at 2 degree of freedom is 5.991 and the calculated value is 0.903. So 903 lies here. So it means we may accept it. So we may accept it at H0 and hence conclude they are not independent. Look at the another type of the chi-square distribution is out of the 800 graduates, there are the 800 females. Out of the 1600 graduates, employees, 1200 are female. So you have to check there. So you have to firstly identify that how many attributes are there. So if you carefully look about the statement, there are the 2 attributes. One is my male and female, and second is my graduate or not. Okay, so you can, this is my 2 and 2, so these are employed and not. So what is that? These are the total 8,000 graduates. So this is my total. Out of, in the town, 800 are females, so these are total females, so female total is there. Out of the 1600 graduates, out of the 1600 graduate employees, so out of the 1600 graduate employed, 120 are females. Now there are the two attributes, one is the male and second is the employed. So can you know what is the H0 is? Null hyphen, there is no distinguish between the appointment on the basis of the sex. Sex means male and female. Can you find the remaining entries? This is 8,000, so this is my 7,200. This is my 1600, this is my 1480. This is my 800, this is 120, this is my 620. This is my 1600, this is my 8,000, so this is my 6,400, and you can find this value as also. Okay, so you can find this. Now you have find all those values, so now you can compute the value of the E and Xi. So this is a 2 cross 2, so there is need of the 1 degree of freedom, so we can compute the corresponding number as this. You can also apply the value of chi-square as by this AD minus B whole square and so on, because it's a 2 cross 2. So you can find this as male 1487, this female as 120, and this. The value corresponding to 1480 is my 1440, so this is my 1440, and since the total is my 7200, so the total you can subtract them, it will be by 5720. Similarly, once you are 1440, it's a 1600, so it is my 160, and similarly you can find the others. Now once you are finding here none of the frequency less than 5, so you can find the value here. So the value of chi-square is this. So the degree of freedom is computed as a 1, so the value of this. So the value of the chi-square is 13.89 lies outside, so we can reject H0, so we can say that distinguish is made on the appointment. Look at one more example is there. In the survey of the 200 boys, so this is my total, 75s are intelligent, have skilled father, their father is also skilled given to you. 85 of the unintelligent boys, these are intelligent, these are the unintelligent, have unskilled father. So it means there are the two attributes, one is the skilled father, unskilled father, intelligent boys and unintelligent boys are there. So how many boys are there total? 200, so it is given to you. Out in the survey of the 200 boys, of which 75 were intelligent, so intelligent boys are my 75. 40 has skilled father, since it is a comma, so 40 has a skilled father. 85 are of the unintelligent boys, have unskilled father, so this is given to you. Okay, so how many attributes are there? There are the two attributes, one is a skilled father, so the two attributes skilled father and the intelligent boys are independent. Now this is a 2 cross 2, so you can find the degree of freedom as a 1, so need only 1 degree of freedom, so you can find the computed value as 80, 75 and 200 is my 30. Now you can compute the table. I can write as intelligent boy, unintelligent boy. I can write like this way. You can write like a column wise also, that's depending upon you, or row wise. Now in this case I have write as a intelligent boy. So what are the values of the intelligent boy is this 40 and 35. So I can write as a 40 and 35 instead of 40 and 40. Similarly for the unintelligent boys, what is that? 40 and 85. This is 40 and 85. Now since I have calculated this value as 30, so what is the value of this is my 45. This is 45, this is 120, this is 30, 50. So you can find this remaining entries all. So you can substitute the value here. You will get chi-square as this. Degree of freedom is now 1, so you can see 8.8 lies here outside, so it is again rejected. So we can say skilled father has a significant effect, means they are not independent. Look at one more example is there. A survey of the 4,000 students of the undergraduate, 4,000 students of the undergraduate, 400 students of undergraduate, 400 students of the postgraduates, They know about their autonomous college. 290 and 310 students of the postgraduates are favored. So 290 are the favored and 310 are favored, while others are the opposing. So there are the two attributes. One is regarding to the autonomous college. Second is the independent of the class. So you can find the remaining entries, I think, easily. So the total is this. Total is 800. Sum is 800. This is 90. This is 110. So now you can find the H0. Opinion is there. Now you can find the degree of freedom 1. So there is need of the 1 values. You can find the 290 as a 300. So the corresponding value is my 300. I can write his as undergraduate, postgraduate. Undergraduate is 290, 110. 290, 110. So this is 300, this is 400, so it is my 100. So you can see that. Similarly, you can find for the other pairs. And once you are computing this, the chi-square is my 2.66. So then what is the value of the degree of freedom is 1. So you can compute this. So the 2.66 lies here. So it means the value of this is may be accepted. So we will reject and fail to reject this one. Hence we conclude that this may be regarded as here. So this is a simple procedure you can find for the chi-square distribution as the attribute test. If you missed any of the previous videos are there, you can simply browse this link. You can find the several other videos regarding the t-test, regarding the ANOVA, regarding the chi-squares, regarding the f-test, and as well as the z-test for their testing of the hypothesis. If you still feel any doubt, you can contact me. Either of my email IDs are there, or you can put a comment on this link. I will resolve your queries are there. Till then, best of luck, students.